Then you cover again your head.
And this one is cross-threaded, for example.
Yes.
Okay? So this is not a good way to do it, okay? And you have also to put the polished face on this side. Okay, you go ahead. Okay, so this is it. Okay?
Okay.
Did you put the... yeah, go ahead. The polished surface?
Yes, I
Okay.
did.
You go ahead.
Okay, so one in between.
Insert it as well. Okay?
This is not in.
Is it?
VB is our supply voltage, and I change the resistor. Initially, I change the resistor, the current is going up, until we are limited by the device because there's a fixed voltage and a fixed current going between these points. Now, if I reduce this, if I reduce the resistor, what happened, I increase the voltage drop on this area, and I can allow higher current to flow until a certain
electrometer and use them for doing the complete experiment. This is the last board that I show you. So the switchboard, you can imagine, not so complex, in which we have here the relays, the different connectors useful for interfacing the system, as I told you, to external measurement instrumentation, and here you have a multiplexer for driving the relay. Here you hatch the gallium arsenide layer for having here the gap vertical in which you can insert your molecules. You can do them also horizontally. In this case, one of the interesting applications is this one, where you create mechanically your gap. So, using a piezo actuator on the bottom, you can press electrode source drain. Here you have a very thin layer of insulating material, dielectric. Below you can put another electrode. So you can apply an external voltage to modify or to apply an electric field, a vertical electric field, to the molecule. So
organic temperatures, it is highly defective, and especially if nano dimensions should be reached, it has been proved that defects overcomes the possibility of technology. So this implementation has been basically abandoned. Another successful implementation that is currently adopted nowadays is the magnetic one. So here the cell is a small magnet with a shape anisotropy in which the magnetization
So we are almost there to the 1 kilowatt value. So I go into the level parameter, okay, and with this knob here I have two cursors, one left which I point on this side, the right one up on this side, and the two actually should correspond to the same altitude, okay, they're corresponding to a flat side. So I say to